All right, we're back. This is page 33 of math analysis, part 2 of that page. And we just came up with these formulas for figuring out reference angles, which, like, if you make a picture, it's kind of hard to get them wrong. I should also mention you can use them in either direction, right? So if you know the reference angle and you know that something is in quadrant 2, for example, you could say that theta is equal to so what are we going to do? I'm going to add, so it's going to be pi minus the reference angle. So it works in both directions. It's an equation. You can use it. It's a formula, an equation. Use it in either direction that you need. So that's going to be useful. So here is kind of the whole point of reference angles. And we've talked about this. We talked about the fact that the absolute value of the trig function of theta, we have a better notation for it now, is going to be equal to the trig function of the reference angle, always. So that means if we can find the reference angle, we can rewrite things. And this is going to be crazy, and I really enjoy doing these problems. So let's take a look. We have this original thing. We're going to write it in terms of an acute angle. So we're going for an acute angle. And what we want to do is first just get a sense of the problem, right? 851, too big. So I'm going to say 851 minus 720 would be 131. So I definitely know. So what quadrant is that? So I know the cosine of 851 is equal to the cosine of 131 because they're coterminal. So that's because they're coterminal. Now, what is the cosine of 131 equal? Let me find the reference angle, right? So 131, quadrant 2. 131 is an element of quadrant 2. So then the reference angle is going to be 180 minus 131, which I think is 49. So that's my reference angle. So the absolute value of the cosine of 131 is equal to the cosine of 49. So we know that's true. The absolute value of the cosine of 131 is equal to the cosine of 49. Now, 131, since it's in quadrant 2, has a negative cosine, right? So cosine of 131 is actually negative. So let me write that. Cosine of 131. That's a degree sign, went crazy. It's actually less than 0. The absolute value of something that is less than 0 is the opposite of that thing. So I'm going to say, therefore, the cosine of 131 is the opposite of the cosine of 49. So that's true. And that's a quadrant 1 angle. It's an acute angle. So I can say that this equals the negative of the cosine of 49. Now, once I get my acute angle, all that I really need to do is cofunction my way over to the other function. So the negative of the cosine of 49 is going to be equal to, using the cofunction identity does not change the sign of something. So I'm going to keep the negative sign, still negative, sine of 90 minus 49. So that'll be the negative of the sine of 41 degrees. So let's say that that's true. Negative of the sine of 41 degrees. Okay. So I usually like to annotate these as much as I can. So this is going to be by reference angle. This is because quadrant 2. This is by cofunction. And there you go. Am I going to have enough room for the rest of these? Probably not. You know what I can do, or try to do? I'm going to move this kind of side stuff up here a little bit. Just kind of work randomly wherever, wherever the space allows. And then, I don't know, let's go for it. So 3192. So if I had to do this by hand, what I would start thinking of is, I know 36, ooh, that's not a pencil. 360, 720. So I got to get bigger, right? So 1440, still bigger. 2880. I'm going to start with 2880. I'm going to subtract, see if I get something between 0 and 360. If I do, I'm done. If not, I'll subtract 360 again. Not really a problem. So I'm going to do 3192 minus 2880, 21, 312. All right. So to start with, we'll say the sine of 3192 is equal to the sine of 312 because of coterminal. So coterm. And then the sine of 312 is equal to, so it's really the absolute value of the sine of 312 because 312 is in where are you going? Quadrant 4. And that means that sine is negative. So quadrant 4, 312 is an element of quadrant 4, which means that the reference angle, theta prime, will be 360 minus 312. So theta prime is going to be 48, I think. Okay, so the absolute value of the sine of 312 is equal to the sine of 48. That's by reference angles. All right, so sine of 48 is, now the sine of 312, because you're in quadrant 4, is negative, which means its absolute value is the opposite of it. So negative sine of 48. And that's because you're in quadrant 4. And then that'll do it for sine, right? So this should be the negative of the sine of 48. We'll check these on a calculator too. And then I'm just going to cofunction my way over. So the negative sine of 48 is equal to the negative of the cosine of 90 minus 48, which means the negative of the cosine of, I guess, 42. So let's check these. Negative cosine of 42. Is there like any chance I could fit 3125 on here? I don't think so. I did not leave myself enough work. Let's just do that one on the calculator. First, let's take a look at the calculator for the previous problems, see how it went. And if it went wrong, we'll fix that. So add a calculator page. I need to be in degrees, so I'm gonna press doc, 7, 2, tab, arrow to the right, arrow down, enter, enter. That's how you do that. All right, I'm gonna check each and every stage. Cosine of 851 equals cosine of 131. True, that's good. I'm gonna skip the next one, which was the absolute value part, and just go to cosine of 131 equals the negative of the cosine of 49. True. And then, so let's see if, does the cosine of 131 also equal the negative of the sine of 90 minus 49, so 41. True. So we got it. We can check the next one. Sine of 3192. I'll just check the final. Negative sine of 48. True. Sine of 3192. Oh my God. 3192 equals the negative of the cosine of 42. True. Killing it. All right. We want to do the last problem. So cosine 3125. So first, what am I going to do? I'm going to do the whole thing here. Let's do 3125 divided by 360. Okay, so I want to do 3125 minus 8 times 360, right? I took the floor of that number. Gives me 245. Okay, so this is 245. So the cosine of 3125 equals the cosine of 245. This is because they are coterminal. All right, that was good. 245 is in quadrant 3, So I want to do 245 minus 180 to get the reference angle. All right, so the absolute value of the cosine of 245 should definitely equal the cosine of 65. True, good. But since the cosine of 245 is negative because we're in quadrant 3, it's really cosine of 245 equals the negative of the cosine of 65. True. Now we'll just cofunction our way over to sine. So negative cosine of 65 equals negative, because using the cofunction identity is never going to change if there's a positive or negative sign in front of the trig function. So let's say sine of 25. True. All right. So I'm going to jot that down. Negative sine of 25 and negative cosine of 65. Let me see what would have happened if I had just typed in cosine of 3125. Look at that. The calculator wants to do this. It changes it immediately to the negative sine of 25. So, and that's why you can't just use your calculator, because it's just going to do the problem for you. But an amazing resource, and you should be using it all the time to check your answers, see if you really understand. Make up your own problems. You can do as many of these as you want. Just make up your own problems, take a look at them, see if they work out the way you think they do. And if they do, good. Make sure you are annotating those. So let me go back to my work, because my work is the minimum quality that you should have. You should be better than me. I've never been a great note taker. So you should have these justifications, right? Let me parentheses. This was cofunction and parentheses. And let me just highlight. These are the things I want to see: coterminals, reference angles, quadrant 4, cofunctions. Did it over here too, because of coterminals, by reference angles, because quadrant 2, by cofunctions. Those are actually better because they're not in parentheses. They're actually like a part of my solution. But anyway, I'm going to come back in the next video and do some more. So I hope to see you there. Hope you're finding this helpful. Play around on your calculator, make up some problems, see if you can do them, and I'll see you in the next one.